Good morning, afternoon, and evening, everyone, and welcome to this week's edition of Postgres Pulse. I'm here with Josh Heyer, my co-host, as well as Vibhor Kumar and Bruce Momjit. This week we'll be talking about WALs, but before we get into that, we wanted to drop into the general chat the guidelines associated with our interaction for a Q&A, as well as our general practices. And for those of you who are attending for the first time, our goal here is really just to talk about Postgres and its entire availability to everyone, whether you're doing so in your own installation on a laptop, could be in an enterprise environment within a data center, or it may be in the cloud. Irrespective of your location and at what scale you're implementing Postgres, our goal here is really just to have a conversation and enable folks as much as we can at all of their layers and advancements of Postgres in their use case. So this week, as I mentioned, we were talking about WALs in our blog entry, which was produced by Tom Brown this week. And the trade-off was identified as, do you handle them as bounded versus the archived approach versus replication slots? The reason or the impetus of this was we had a customer who was actually working with us within support team who was looking for some guidance and some help on how to set their WAL keep segments. This is really kind of one facet of what is really a much bigger picture in terms of understanding how you should handle WAL and at what way you come about approaching your replication solution. So before we get too much into that example, I'd like to step back and allow the experts, of course, Bruce, if you could start, to explain what the purposes of WAL within Postgres, the write-ahead log, as well as what the three main use cases are that we generally see people practicing when they're going about their definition of their replication strategy.
Sure. So WAL in 30 seconds. Here we go. Basically, the write-ahead log has, I think, 3 or 4 purposes. The first purpose is crash recovery. Durability requirement as part of ACID is accomplished by the WAL. When you crash, we reread the write-ahead log and replay to get the system back to a consistent state with all committed transactions recovered. The second use is for point-in-time recovery. That is when you effectively can restore your system to some point back in time, or you may use it for continuous archiving where you effectively want a backup that is contiguous. So whenever the machine dies, you can take another machine, take the base backup, take the archive logs and replay them instead of just worrying about a backup that happens every night and potentially losing almost a day's worth of data. Obviously, point-in-time recovery, continuous archiving is usually the term I use because it comprises the idea of recovery, but also the idea that you're continuously archiving your data for recovery at some point in the future. That's 2. 3 is streaming replication, right? Where we're using it to effectively have a replica which remains current with our primary machine. Now, there's kind of a 4th use case with the write-ahead log, which has to do with logical replication and the concept of replicating only some of your data to other systems. That's sort of a hybrid, sort of maybe 3.5, let's put it that way. So having those requirements, some of them are really easy. For crash recovery, Postgres knows right away, okay, I've performed a checkpoint. I've flushed all my shared buffers down to durable storage. I don't need that WAL anymore. So for purely crash recovery circumstances, people can set WAL min, the min and max size of their WAL directory. But in general, most people don't have to play with it because we kind of know exactly how much we need. And we know when we do a checkpoint, we don't need it anymore, we can get rid of it. For continuous archiving, it's a similar case. We know we're done with the WAL for crash recovery. If we've archived the WAL over to an archive location, we don't need it anymore, we can then get rid of it. It's the third case that really is the real tough one.
Now you got another machine someplace.
Yeah,
right?
that's another
you
machine.
Got a flaky
right.
network, maybe.
It's like when I know exactly what I'm using it for, I can recycle it just fine, right? But when I got this other machine I don't know about, then it becomes tricky, right? So you have the one case where you're basically like, well, I'm going to keep it for a while, and you define what a while is, and you assume that your standbys are never going to get more than a while behind in replaying. And if they do, you can always have that standby go to the archive location. So you don't necessarily have to keep it in the PG WAL directory. Standby gets too far behind, it can go to the archive location, start pulling stuff from there. Once it's gotten as much as it can, it then goes back to the primary, can then resync up. So that part kind of works really well too. But then, there's the question of, well, if you don't want to have an archive location, you don't want to play with that kind of thing, how much WAL do you want to keep just to kind of make sure the standbys don't have to go to the archive directory, or maybe you don't have as much archive directory as you want, you only keep a couple days, something disappears for a week, right? Like how do you handle that?
Right.
So
And there's pros and
logging for
cons to each of those, right? To each of those approaches.
Yeah, I mean, you can basically say, I'm going to keep, 100 gigabytes, right? Maybe you've got a big drive, and I'm just going to keep 100 gigabytes, and I'm going to assume that nothing's going to get farther away than 100 gigabytes. And that's a safe case. So at least it's never going to get more than this size. And if somebody disappears for that long, that's their problem. That standby is going to worry about it. And again, hopefully I have archive WAL somewhere else. I can have the standby go to the archive WAL and then come to me once it gets as much of the archive WAL as it can. The other solution is to use the replication slots, where you have the standby record, hey, I'm now hooked to you. I'm going to be getting WAL, and I'm going to tell you where I'm currently reading from. And I want you to keep around exactly how much I need, so that if I go away and I come back, you should reserve that missing segment for me. And the concern there is that if the machine goes away for too long, or you decommission a machine and forget to remove the replication slot, then you potentially have this unbounded amount of WAL, at least up until Postgres 13, an unbounded amount of WAL, where you could effectively have the standby causing the primary to run out of disk space or to run out of write-ahead log space.
Well,
and
and
that's a serious problem.
you say up until PG-13. This is the bit that was mentioned in this week's blog post, right? About max slot WAL keep size.
Mm-hmm. And that it's sort of saying, you're telling the primary, keep around as much WAL as all my standbys need, but I'm going to put a cap on that. I'm going to limit, I'm going to say 50 gigs. I don't care how. I'm going to try and keep around as much as you need, but effectively, I'm going to cap it at a number. What used to happen, unfortunately, before replication slots is either you'd have this unbounded amount, right, where you don't limit it, or you would limit it not even knowing if the standby needed it or not. So you'd set it to 20 gigs, and if you're not using replication slots, the primary has no idea if anybody needs 19 of those gigs or not, right? And you just keep them around because that was my limit. So that was, I think, the big piece that was missing, was you could have it unbounded, or you could cap it, but it would be always allocated, instead of what we now have with 13 is a cap, but also because replication slots are used, we now have the ability to say, yeah, I know my limit's 50 gigs, but I only need 2. So let's get rid of 49 of those, and let's just keep the 2 that I know I need because of replication slots. Before 13, you either had the unbounded if you use replication slots, or you just had this big blob that was always kept no matter what. And that was what was really prompted the feature in 13.
Got it. I think we've definitely seen prior to 13, those that tend to be running between 9 and 11 as an example, where you see one of the first couple of examples where you might have a situation where that standby gets far enough behind, either because it's handling traffic on its own, or because it happens to be a machine which isn't exactly equivocal to what you see in your master, that you potentially run into a situation where your primary or your master ends up basically locked, right? It ends up going down because it runs out of storage at some point. You can also see performance issues, right? If your archive becomes so vast that you're running, tens of terabytes as an example, and it can't necessarily process what it needs to, you end up with this cascading effect, right? Um, a little bit more about what changed in 13. How does that differ, and what's the big advantage to that versus what it's been to this point with replication slots and the configuration you can do there? Vibor, maybe you can go into a little bit of detail there.
Yes, again, it's a new feature in the Postgres 13 which allows users to restrict how much of the WAL file you want to keep on the primary for each slots which are getting used by the standby or some tool like PG receive xlog or PG receive WAL log, or if there's another tool like PG based backup, right?
Yep.
So again, this is a kind of capability which people have added, but again, this is not really solving the problem, in my opinion, because if you look at when people are going to use a slot, most people use the slots in terms of using the standby. So if they have a standby, they prefer to use physical slots so that standby can catch up with the master quickly. They don't prefer to go to the archived WAL files because archived WAL files are cheap storage. Plus, it's on over the network. It takes a little time. So there will be some delay, and standby purpose is to provide a high availability and of course reduce the recovery point. I mean, there's a RPO and RTO requirement too, right? And they want to meet that requirements, and that's why slot always come in the picture. But again, with slot till 12 there is a drawback too, in the sense if you have a slot open and your standby is no more there in the cluster, right, then your master will start accumulating so much WAL file that the disk will be full and master will be down, and you don't want to go into that situation. And that's why new parameter was added in the Postgres 13. But overall, if you look at from a bigger perspective, right, exactly what you want to achieve. You want to achieve high availability. You want to make sure that your standby is always close to your master. Then only the high availability makes sense, right? If your standby is far behind, then your master and your master is accumulating WAL file due to some other reason, right? Then it means something is wrong in your whole environment. You're losing the high availability, the durability of your data altogether. So you have to look it from all the angles, all the perspective. And of course, you would like to create a baseline too. Exactly, because of the network latency, your standby may be a little behind from the master, and this much of the WAL file you needed. You always predict your workload based on the workload, how much master is going to generate WAL file, that much of disk space you need to have. And you would like to monitor this whole environment, right?
Sure.
Because you are providing the high availability. Plus, some people use standby for scalability purpose too, like read query purpose, right? And that's why you would want to make sure that both are always up and running, always in sync, and something weird is going on, you should be able to take action. And for that, you need to create alerts. So, I mean, replication slot is a very nice feature, but it doesn't take away the monitoring of the environment. You
Right.
should monitor that. And if you include any slot wall file or the size based on the size, how much wall file you want to allow master to keep for the standby, right? If you go into that direction, and if standby is going far behind and standby cannot sync up with your master, then something weird going on in your environment, and that you can identify and find out based on monitoring your workload or what is going on your master and standbys.
Right.
Sounds
I
like a
think that's a
pretty.
great point, right? Sorry, go ahead, Josh.
No, it sounds like what you're saying on top of it. Not only do you need monitoring just to make sure your setup's working, but you have to define what high availability means in your situation,
Correct.
right?
Yeah.
Like if you need your transactions committed to your secondary servers before you can trust them, that's got to be built into your setup as much of
Yeah.
a performance hit as you might take for that. You can't if you need that, you got to make sure that that exists. You got to monitor for that, but you have to define that in your setup. If you don't need that, you can get away with a lot of other stuff, but
Correct.
you got to
Yeah.
decide that up front. You can't just throw it together and say,
Yeah.
yeah, whatever we got, that's what we got.
I mean, what's an acceptable? Because if your standbys are falling behind, they're delayed. So what's an acceptable delay to you, right? So
Right.
you're
Correct.
right, Josh.
Yeah.
You have one case. I'm synchronous, so therefore I don't want any delay. I mean, technically, I have a blog entry about it, but technically, the this when you're in synchronous replication mode, the commit appears on the standby before it appears to other sessions on the primary. And I haven't blogged about this, but I have a blog that's coming in a couple of weeks that talks about exactly this.
Yeah.
So that's in synchronous mode. But then if you're in asynchronous mode, what is an acceptable delay, right? Is it
Correct.
a minute, an hour, a second? I don't know, right? And you have to figure out what is acceptable to you before you.
And this very likely goes up into your application architecture.
Yeah,
You
right.
can't make
exactly.
a decision for your data storage in isolation there.
Yeah.
Yeah. Or if suppose somebody comes in and they do some kind of a weird activity on the master side, which can generate a lot of WAL files, right? For example, somebody's doing a reindex on the system. And if you have and you're doing a reindex across the data, all the tables in the database itself, right? Then it will create a lot of WAL files. So again, you need to plan it accordingly. That's why people say that if you want to do maintenance activity, do those maintenance activity when there is a less workload on the system. This way, the WAL generation can be in control.
Which again, if you're monitoring your
Yes.
activity, you'll be able to make an educated guess as to what
Right.
that might be.
Correct.
Now, Vibor, you had said something a minute ago that I want to tug on, but before I do, I just want to remind everyone, if you've got any questions, whether it's related to WAL or obviously replication or anything we've talked about here or anything we haven't relative to Postgres, feel free to drop your questions into the Q&A. We're going to answer them actively as we go through and hopefully be able to expound on them, obviously. Now, Vibor, you'd mentioned something a minute ago about being able to measure the appropriate amount of lag. So my question is, from either of your perspectives, but Vibor, I'd be curious to hear from your experiences what you've seen. Is there some sort of magic number or relationship or formula that we can kind of look at that says this is right for my environment, right? That's oftentimes when you see people coming from, let's say, different DBMSs, a lot of things in this sense are handed to them. So from a Postgres perspective, how do you know what the right amount of lag is? Is there a way to calculate that?
Yes. Interestingly, Postgres has all those views for the users where you can just query your master and find out exactly how far is your standby. So what you do, again, for finding the right value, you need to monitor your system. Generally, what people do, they know the application workload, how much workload will happen on the system, or what is the TPS they're expecting from the application side. In the test environment, they do all the benchmark, and they find out how much WAL generation is happening with the normal workload in the test environment. Based on that, they create or provide a disk space for the PG WAL directory. And based on that, standby catch up with the master. But ideally, if you want to look at the formula, again, I would say it's not really a perfect formula, but gives you a way to calculate exactly how much WAL file or size of a disk you want to have on the master side. And based on that, you would like to monitor your master and standbys. So the basic formula is that based on a workload, how much WAL generation is happening by per minute basis, and how much is the latency between the network of master and standby. You calculate those two together and you multiply it and you see, okay, your standby is way behind, like a minute behind from the master, and your WAL generation is happening in 1 minute. You have 10 WAL files, right? Then you multiply those together and you keep, and of course, you keep some extra buffer too. Like I just do that, multiply with the 2. So it's more like number of WAL generated per minute into the latency between master and standby into 2 twice, because it gives you some buffer space on a disk for your monitoring and to take some action in case something weird is going on in your environment. So this is the normal kind of a thumb rule which I use. It's not a perfect formula, but it gives you some idea, exactly how much space you would like to have on your master side for the WAL files.
And of course, you still have to plan for your peaks, right? So
Correct.
it may not be a situation where your average or your mean is going to fall to half of your peak, right? Your peak could be substantially above that, but I think as a rule of thumb, that makes a fair amount of sense. Bruce, from your experience, is that I guess a pragmatic way of approaching how to ensure you've got enough, basically wiggle room or buffer in terms of your local storage and what you can expect from a standby strategy perspective for WAL?
Well, you know, it's funny. This goes back to something we talked about like a couple weeks ago, I think, in Postgres Pulse, where we talked about kind of setting a baseline of what's
Yeah.
reasonable. And I talked about, I think, you know, one of my Mocha devices was, you know, starting to throw some ping errors. And my
Yep.
wife said, you know, it's not working. The laptop's not working right. I said, I think I know what the cause is. So you kind of have to, as Vibor said, you kind of have to know like what's a reasonable amount of WAL, what's an acceptable amount. The classic case for me for WAL is that in the old days we used to be able to tell people how much WAL they were missing, but not how old the WAL was. Okay, and that's changed in the past couple of years. But what we used to do is, you know, imagine somebody places an order at 2 a.m. Okay, and there are no orders for like 7 hours, right? And you show up and you're looking, you're like, oh well, I'm only like, you know, 3 transactions behind, but I'm 7 hours behind, right? So it's sort of like you have to look at both parts. You can, as I understand it, Vibor, maybe you remember when we added the ability to determine how old the WAL was. We had to add some time number, you know, into
Yeah.
the WAL stream. It's probably 3 or 4 or 5 years ago. But you got to look at how the volume you're behind and also the time you're behind, and you may care different amounts, you know, based on that. If you're issuing queries in parallel, you're doing like a PG pool case, you're doing read balancing over, then it gets really complicated because then you either have to make sure that you're very careful never to do a read in one transaction that is assumed to be the same in a later transaction, right? Typically, if you're going to do that kind of read and then write, you want to do that in the transaction block. The pooler will automatically know that has to go only to the primary, and I can do my read-only queries over there. But again, that's when it gets kind of confusing. What is your, as Josh said, what are your parameters? What are your applications expecting from these replicas? Is it data warehouse? You know, a lot of times data warehouse, you're like, oh, it's an hour old. That's, you know, nobody's going to buy more socks in the last hour, right? You don't
Or
care.
you just don't care. You're going
You
to
don't care.
be an hour behind all the time, but you're doing a
Right.
monthly report.
I mean, frankly, if you're using Postgres in both places, you're lucky to be an hour behind, because the old days, you'd have to have a separate data warehouse thing that only updated like every night or every weekend, right? So like you know, you're living the life of Riley, as they say, where you're just kind of, hey, it's only an hour behind. But again, yeah, it's really like, what are these replicas for? Are they in the same data center? Can that network go down? Do we care if that network goes down? What's our retention for the archive directory, right? Have we configured our system so if it comes to the primary doesn't have the WAL, does it have access to then go to the archive, pull as much from there, and then go back to the primary and say, hey, I know I asked a while ago, now I'm much more current, I'm sure you'd have these WALs. And
Right.
then that brings them up. So a lot of people don't understand all the pieces that are there. I think that's really to me, that's the biggest part.
So,
You've got,
on that note, I want to tug just briefly on something you said a minute ago, Bruce, because you mentioned the mixed read and write scenario, and
Mhm.
this can be a really common application side. As a developer, this is something you can do without realizing it, or introduce when it wouldn't have been introduced originally. You've got a bit of code that is just doing reads and writes. Your performance is suffering as your data grows, and you see this read-only replica and think, hey, free performance. I just
right.
change a bunch of the read calls to hit the secondary, and I'm good to go. And it works, except for the mixed read and writes.
Correct.
And I've seen this where all of a sudden you just get random data corruption in your application, not in the database, in your application, because you're writing stuff and then you read it back and it's not there.
But ultimately, the problem is You see it fail more when you're doing that, but you can get the exact same failures on a single machine. So it's not really a question that you're using the replicas incorrectly. The bottom line is this would have failed on a machine. It's just the delay is longer. So you see it more,
Well,
right? But if you're
anytime
doing,
you throw time into the mix.
right, but if you're doing a select and then an update without doing a select for update in a single transaction, right? You know, you're going to have this problem. And in fact, we have, we have serializable isolation mode to effectively like detect that. I mean, that was one of the values of the thing. But effectively, the best solution is to really have application developers. This is not easy to really help them understand if you're going to do a select and then you're going to take update action or modification action on that. You need to do a select for update. It has to be in a transaction block. That's true whether you're using replicas or not. Replicas are going to show you the failure sooner, but that may be a good thing because that way you'll see it sooner instead of it happening,
Yeah, the worst logic errors are the ones that don't break.
right
Right away. All of the multi-threading code I wrote when I only had a single core.
Important, right? Until it's Christmas time and you're really sweating. Yeah, absolutely right.
Yeah.
Josh?
No, go ahead, Jamie. I was going to say you got some housekeeping to do.
A little bit, yes. So we're going to wrap up with a bit of news. However, just a reminder for folks, if you guys have any questions, always feel free to post them here. You can also post them on Postgres Pulse at Enterprise DB. Equally, you can also reach out to us on Twitter or on LinkedIn. We will have another blog up next week, and following that, another session. But we want to wrap up today with our news. There was a pretty sizable and unique event that occurred last week. And Bruce, if you could dive a little bit into that, I'd be interested to hear some of the lessons you got out of that.
Of course. Last week we had Postgres PG Con. That conference is normally held in Ottawa, Canada. But of course, because of the quarantine this year, it moved to an online format. Monday was tutorials. Tuesday, Wednesday were talks. I'm sorry. Tuesday was tutorials. Wednesday, Thursday was talks. Friday was the unconference. I thought it went very well. We had, I think, at least for Wednesday, Thursday, we had 3 tracks simultaneously, about 60 to 70 people in each track. So, pretty good attendance. Had some technical glitches, which, are unfortunate, a part of the learning process, because you're using one technology like Zoom for presentation, and then you're using a different technology for consumption, potentially.
Sure.
The same thing happened when they did the Percona conference two weeks ago, the online, the 24-hour conference that they did, which I thought would use the same pattern. Thought that went very well. I have a conference for Madrid this week, and I have one for Brazil this week, so both online. Kind of interesting. So a lot of stuff's kind of shifting online. I did put out a blog entry on my website, momgen.us, this morning. I think it's called Lessons from the Online Conference Trenches, because there have been, there is some new things you have to learn when you're presenting online. There's new things for organizers when you're creating a conference online, and of course, new things for attendees. There are things you can do easier when you're online, actually, as an attendee, that you can't do. You're missing some things, and there's some advantages. So I think we're going to see a lot more of this. I don't think I have any conferences scheduled until October, which is kind of strange. Let's see what happens. We may be seeing a lot more of these, like Postgres Pulse and Postgres Vision will be online. That's coming in June, so we're looking forward to that. But I think there's a little bit of learning for people to do, but also opportunities. And again, being able to do a conference for Brazil and Madrid in the same week, that's kind of nice. And, I enjoy really getting a chance to talk to those people and evangelize Postgres. So it's a nice opportunity. Would we have chosen it on our own? No. But this is, you make lemonade out of lemons, and, it's a good thing. And I'm certainly enjoying it. I'm enjoying our Postgres Pulse time together. I think that's kind of interesting too. And let's just continue to learn, continue to improve, and yeah, this may be a new opportunity for us to evangelize.
It's a
That's,
great opportunity to kind of hone our skills, right?
Yeah.
yeah,
Yeah.
absolutely.
Yeah.
Both as attendees and as speakers. Vibor, were you going to say something? Sorry.
No, I agree with Josh comment, right? Exactly. It's a good opportunity to learn and grow. Yeah.
Absolutely. Well, with that said, as Bruce had mentioned, there's a couple conferences that are coming up over the course of the next couple of weeks. And as we get to the latter half of June, we've got Postgres Vision. Hope to see all of you there, as we will all be there. And as I mentioned, we've got another blog entry coming out next week and a subsequent Pulse episode the following Monday. If you guys have any questions or suggestions for future topics, feel free to reach out to us. We are always listening. Thanks, everyone. Take
Thanks,
care.
Jamie.